So welcome to another class of cloud computing. So to start off with, I would like to discuss a few things first with respect to the weekly meetings that we were talking about a few classes earlier. And we kind of have figured out a schedule for it and we would like to move forward with it. So I would just like to inform you about the process that we are going to follow in order to kind of implement the meeting, right? So essentially, to remind you, what I'm talking about is basically a meeting to discuss about the progress that is being made with respect to the research project. Okay. And what we have come up with, essentially, for now, is basically a bi-weekly meeting with the TA, okay, wherein she will kind of share probably about 9 meeting slots, and based on your availability, you will pick a meeting time. All right, and there will be some incentives or grading that is associated or that is going to be associated with joining the meeting, with specifically some parts being allocated for the points distribution to the attendance itself. That is for showing up, you will get some points, and a discussion or basically a reporting of what you have done. Okay, individually speaking, whatever your responsibilities are for your particular group, at least for the first meeting, and basically from after the first meeting, you would essentially have to discuss the progress. Okay, so basically the delta that the differences or the progress that you have made from the previous meeting that you have reported, whatever you're working on, and then what you have achieved in the 2 weeks since you have last met, right? And along with that, you would also need to talk about your future directions or your future plans of what you would be working on for the next few, not next few weeks, but basically the next week or so, until you meet again, right? So the specific point distribution as to like how much point will be given to each of these particular aspects, we will kind of decide that soon enough. But essentially, this is what we are looking for with respect to the meeting. And the goal is to make sure that we are kind of aware with respect to what you're doing, and that we kind of have an understanding of what everybody's responsibilities are within the project, with respect to who is doing what part of the project and whether they're doing things or not. And to make sure that we can avoid any kind of like situation where towards the end of the deadline, there is a situation where, 2 or some members have not done anything, and then the other members are basically carrying the load of the entire group, trying to get that up and running, right? So we just wanted to like keep a track of that, and also in the process present you with feedback if it is necessary, depending on the information that you provide us with, and then work on that, so to make sure that you are steadily kind of being on track, or so to speak, right? So what we're not expecting during these meetings is to see any kind of final product or any kind of final prototype. This is more like a work in progress reporting that is expected out of you. We just want to make sure that you would be able to, or we just want to make sure that you know what you're doing, and you have a plan of action as to like what you will be doing on a shorter, on a smaller scale, right? Rather than waiting for like 3-4 weeks before it is too late and towards the end of the semester. We just want to make sure that everybody is on track and doing their part. Okay. So as far as the first meeting goes, we are still working on it, but hopefully we can arrange for something by the next week. So the first set of meetings, at least preferably from our side, could be next week itself, right? So we will share the time slots probably by the end of this week. I'm still in discussion with the TA. I don't know if she is on call right now. Probably not. So, okay, so I'll talk with her later on, but on Discord for the class server, and again, a reminder for those who have not joined the Discord, please do so. We will share the time slots that is favorable for us, and then everybody can pick and choose which time slots work with you, right? And of course, regarding the time slots itself, it will be around like 30 minutes time slot per group. Okay, so that is what you're looking at. And does anybody, at least who are on call, have a problem with morning time slots?
Will this be during the week, I assume?
Yeah, weekdays.
Mornings aren't preferred for me.
Okay, so all right, so mornings not preferred. So we will probably try to keep it after 6:30 p.m. Does that work?
Yeah, that works.
Right, so after 6:30 p.m. and we will try to kind of span that out to, well, that depends on what works for her as well. But we will try to keep it by 10 p.m. We will try to wrap things up. Okay, no later than that. So, okay, so we will prepare according to that time window, and we will share probably 9 time slots that works for the groups, and then we will share the time slots on Discord. Okay, so please make sure that everybody is on Discord, and so you can see what time slots are available, and you can have a discussion on picking and finalizing your own time slots, right? So again, as I was telling you guys, so we will preferably have the first meeting next week, and after that we have the winter break, and then you have the submission window probably around this week for the phase 1, right? So which is basically expecting your literatures that you have gathered for your project, getting at least a draft of your problem statement as to like what you would be working on, or what are the different issues that are present in the domain that you're pursuing, right? So have some understanding of that. Maybe look for some data sets that you're going to analyze, collect some of the data sets, or at least give a plan of action as to like how you're going to be looking for data sets and stuff like that pertains to your domain, whether they will be like academic research papers or news articles or white papers from industries, technical report, and things like that. So collect that, kind of create a repository of those data sets, and then after the submission of phase 1, you will kind of go over that data set and get an understanding of like which ones are relevant and you would like to keep, and which one you would like to essentially kind of drop from your collection that you made initially from phase 1, right? So that's basically in the understanding. And again, remember, we want to know that you have an idea of what you're doing, that you're on track, and you have a plan of action that you are going to follow with respect to what you are going to do in the upcoming weeks. So that is what is expected from us, right? That is what our expectations are. We do not expect to see like, completed products or anything of that sort, right? That is something that we will be evaluating and providing you feedback when you do the final submissions for each of the phases, right? The biweekly meetings, again, is to give you feedback if you need so, right? To make sure that everybody is doing their part, right? And then to have an understanding that everybody or the entire group, individuals included, have a plan of action that they are going to follow for the next week, and to make sure that every time there is a meeting after the first meeting, that there is some semblance of progress that is made with respect to acting upon your plan of action that you have discussed in the previous week, right? So that is basically the goal of the meetings. All right. You're not expected to give us like a briefing of the papers you have collected and what are their contents. It is not expected. If you would like to do so, you may do so. That is up to you as a group, right? But remember, the time slots are 30 minutes, and each group has probably about an average of like 4 members, right? So some groups probably have 5, I think 2 or 3 groups. Most of the groups have 4, and I think one group has 3. Okay, so just decide, like, make sure that everybody gets to speak about their part, what their responsibilities are, what they're working on, and what they will be working on before the next meeting. So when the next meeting comes, you will talk about whether you were able to achieve the plan of actions and stuff like that, right? And so after the submission, we will have the next meeting right after that. So the expectation is you will have a clear understanding of where you want to, take the, or what direction you want to take after you have made a submission for phase one. And you will probably get your feedback of phase one in the next week or so. So the next time you meet, you will basically make a collection of all the discussions that are feedbacks that has been given for phase one, and talk about the progress that you have made comparing yourself to the previous week's meeting, right? So give or take, as far as my estimation is concerned, we will probably have like 1, 2, 3, and then maybe 4, 5. So no more than 5 meetings, give or take, right? So 4 to 5 meetings is what we will have for the remainder of the semester, okay? And essentially, once this paper presentation task is over and your exams are submitted before the winter break, before going into the winter break, then basically the only thing that is left for you to focus on is the projects themselves, right? So it is expected of you that you do a good job in that, right? Or at least a comparably good job with respect to the content that you produce, because there will be no other distractions for you with respect to assignments, and I'm not considering quiz as a matter of fact as a distraction, because the extent of quiz is to basically just make sure that you're keeping up to the materials that is being discussed in class. So they don't have any specific deadlines for the quizzes that I'm going to upload from now onwards, and will not produce any kind of deadlines as such. We will just stick to the original plan of action, where we had talked about the fact that just make sure that you finish the quiz in a timely fashion, okay? So I'll keep the deadlines open for the quizzes that I'm going to upload from now onwards, so you can access them at any point of time, and there wouldn't be any kind of time crunch or requirement where you have to finish the quiz on a certain date, right? So that will give you some flexibility and breathing space with respect to when you would want to attempt the quiz, and you can do it at your own time, okay? And just make sure that you are keeping up to pace with respect to the materials that we're discussing in class. All right, so I'll open the floor for questions at this point of time. If any aspect of the discussion is not clear, if I missed on something, please feel free to raise the issue, and we can talk about that real quick.
Yeah, I had a thing. I haven't talked to the members of my group, but morning times are actually great for me. I don't know if you want to throw that into the ring or not.
Okay, what timings are you talking about? Like, can you give me a time slot?
Oh, my day is fairly free form because I'm a TA. So really, I would have to talk to the group, but anytime between 8 and noon is great for me.
8 to noon. Okay. All right, we will take that into consideration, not a problem, because there's a lot of variables that are involved here, no doubt, right? Because some people are working full-time, maybe some of you are working part-time as well. And for those who are full-time students, mornings won't be that of an issue, but we also have to keep in mind of our side as well as to when we are available as well, right? So I will figure that out, and we will share that information on Discord, and we can have a talk about that, and we can kind of finalize everything by the end of this week, okay? Another thing that I would request all of you to do is to, can you just open up your Discord and probably try seeing that, can you guys join your respective group channels? Is that something that you will be able to do as participants, or do you need admin access for that? Can somebody just check real quick if that is possible? So if you notice that I have created like group channels, specifically from group 1 to group 9, which is basically reflecting the groups that we have and the numberings that we have on Moodle itself. So
I can get it.
Yeah, so please join your respective group channels. So once you join your respective group channels, I will just log those groups, and me and the TA, we will join every group as well.
It doesn't ask you to specifically join. I was just able to post in the group 2 channel.
Yeah. So just join the group for now because it is open for all. There is no restrictions as such.
Okay.
So for now, just join the group that you belong to, and make sure that all the groups have joined their respective group channels. Once everybody has joined their groups, then we will lock the groups out after we join it as well. So please, again, for those who are present on call right now, please remind your group members as well, for those who are not present. And when you watch this lecture offline, for those who are unable to join the call right now, when you watch this, please make sure you do this exercise, if you want to call it that, and join your respective group channels. So again, remember the group number that you have been assigned on Moodle, you would want to join that group channel specifically, okay? It's not about like anything about privacy or confidentiality as such, but we just want to minimize the footprint of discussions to, about the respective projects within the group channels itself and not on the general channel. Okay. All right. So all right, give me 1 second. So use this link. I've posted that on the Zoom chat for those who have not yet used or joined Discord. So please make sure that you do so probably by tonight and no later than tomorrow afternoon or so, because we will start posting the information basically on Discord around that time. Okay. And the information about the meeting times and stuff like that will be present in the notes resources channel. It's there in the information subcategory. I'm talking about Discord specifically and not the text channel. So you will probably get it there. So that's where you'll be keeping an eye out for. And I will also send a message on Moodle separately, kind of, replicating the information to make sure that everybody has received that information, okay, regardless they're on call or not. Okay, any other questions? Is it clear the purpose of the meetings? Okay, so take a minute, think about it. If you have any questions, at least for those who are on call, you can ask them right now. Otherwise, I can clarify them over Discord as well. If you want to send me a quick text, I can just respond back to you there as well. So no questions? All good for now? Okay, I'll take that as a yes. All right. So let me just ask this question. Let me actually just give me 1 second. All right. So in the last class, we had started our discussion about cloud computing itself, right? We were talking about the architecture of cloud computing, specifically with respect to how you can build your own cloud computing platforms. What are some of the different options that are available to you? And we were also discussing about the service models, right, of cloud computing, which was the 3 major service models as we know of is basically infrastructure as a service, platform as a service, and then software as a service, right? And we also had discussions about thick and thin clients, talked a little bit about the notion of cloud computing, whether it should be considered as a centralized computing within the data centers, or whether it is basically a practice of distributed and parallel computing. Talked a little bit about the data center networking, remembering the fact that all of the infrastructure that basically supports the paradigm of cloud computing needs to be present in these singular location that is known as data center. So basically within a data center, what you have is all of your physical resources. That is basically the racks of commodity hardware and software that will be running, right? They will be supported by multiple switches in order to enable the networking within them. And then basically there will be load balancers that will be there to keep a track of the fact that no one section within the data center gets overloaded by the request of the user, or there is an over allocation of resources that is taking place, right? In addition to that, there are also access routers and gateway routers that basically bridges the gap between the infrastructure that is present on the data centers or within the data centers, and then connecting that with the users who will be accessing it through user interfaces, either web browser based or command line interface based, in order to kind of communicate with the actual resources that will be there, right? We also talked about the cost model analysis, a comparative study of what are the typical costs that are involved when you think in terms of the traditional IT infrastructure that needs to be kind of procured and maintained by the organization itself, okay, versus subscribing to a service that is provided by a public cloud computing service provider like AWS or Azure or Google and stuff like that. And we talked about the different types of costs that are involved there, and what makes cloud computing a very alluring option for companies who do not have much capital in order to set up their IT infrastructure, right? But they do have an idea about the functionalities that they would like to implement in this particular domain, right? So continuing those discussions, we will talk a little bit more about the different cloud design objectives, like what you have to keep in mind, right? And we will also talk about some of the different softwares, that the open source softwares, specifically speaking, that are available or that you can keep in mind if you're trying to develop something like a private cloud, that is a cloud that is designed specifically for an organization and for the employees and clients of the organization, right? So we will talk about that, and then we will move on to the design objectives of the data center. That is, if you are building a data center, what are the different design challenges that you have to keep in mind? And specifically, the discussion that we are going to have with respect to the data center design is with respect to cloud economics, right? Again, everything will be boiling down to cost to a certain degree. So we need to have an understanding of what cloud economics is. Specifically, what do we mean by economies of scale, right? And how does that play a role in designing and developing a data center, right? And then we will basically wrap up the discussions about the fundamentals of the cloud computing architecture. And then from next class onwards, we can probably move forward discussing specifically about AWS and its constituents, okay? So again, as we had discussed this many number of times previously, just give me 1 second, I'm just waiting for this to go away. All right, we want to essentially move the processing to where the data is located, right? And essentially, in doing so, we don't want any kind of desktop computing to be present in this particular scenario, right? Specifically, what we want to do is we want to move the notion of all desktop computers to the data centers, such that the process of ownership, or at least the facets of ownership, maintenance, and management of all of these different hardwares can be shifted. Essentially, the responsibility can be moved to the CSPs itself, right? Or the cloud vendors. So these are basically interchangeable terms that we're going to be using. Sometimes we can call them cloud service providers in whole. In short, that will be CSP, the acronym itself, or sometimes we'll be referring to them as cloud vendors, essentially, right? So essentially, they mean the same thing. It is essentially the service provider, okay? And then the provisioning of the services is based on what we talk about as cloud economics, right? And then whatever services that we are going to be provisioning as a service provider, right? So this is from the perspective of the service providers themselves, right? Not from the perspective of the client. So if your organization is also the service provider, then you have to keep these things in mind, right? Otherwise, you just need to be aware of these things as a client, right? So most of the cloud services are typically designed or needs to be designed in such a way that they can be provisioned on an on-demand basis. So that means whenever a client comes, requests for resources, you kind of have to be in a position that you can provision those resources, right? It could be in the form of an infrastructure. It could be in the form of a platform with certain library or API supports, or it could be in the form of just availing some of the software services that is present and accessed through the web browser interface and stuff like that, right? One of the important kind of connected feature to this on-demand service is that when you are being provisioned those services as a client, you are going to pay only for the functionalities that you're using, right? And there is no universal kind of rule with respect to what this pay-per-use structure is going to be, because that is going to vary from service to service, right? So that means that your cost model with respect to what you're going to pay is not going to be the same when you are, let's say, requesting or demanding for let's say a compute resource, right, which is a category within infrastructure as a service, compared to, let's say, requesting for an environment, let's say a container service that will be able to run your machine learning models, versus subscribing for a service like the Office 365 suite and stuff like that, right? So all of this information is basically kind of wrapped up from the service provider's perspective into what is known as a service level agreement. So one of the first important things as a client that you will come across and that you need to pay very close attention to is basically the SLA, okay, or better known as service level agreements. And the reason why this is important is because this is basically the contract that you are going to be given that will kind of lay down the share of responsibilities. Okay, share of responsibilities with respect to telling you as to what the cloud is going to keep a track of, right? Or what they will be responsible for, and what you will be responsible for as a client when you use their services, depending on the type of service that you're demanding, right? So here, there are certain aspects that are important. Some of the key aspects with respect to the share of responsibilities that will be present in the SLA, and you kind of have to be aware of it, is with respect to the QoS factors, okay, the quality of service factors that will be given to you in your service, right? And what is the cloud service provider promising you with respect to QoS, right? And when you think of QoS, the quality of service, right, there can be many subcategories that you need to be aware of depending on the type of functionalities that you are executing on over the internet on this cloud service provider's platform, right? So one of the most go-to QoS factors that you need to be kind of aware of is known as availability of your services, okay? So you need to be aware of what promise the cloud is making with respect to the availability of the service. And by availability, it essentially means that their servers don't go down, it doesn't crash, what happens in the event of a crash, who is going to be responsible, how you will be kind of reimbursed for the loss of your work if that takes place, database services, how will that be available? So there will be a number that will be associated with it. And basically that number is a percentage value going from 0 to 100%. Okay, so that is basically the unit or categorization of availability that you will find. Similarly, you will also look into other factors such as latency. That is, how much is the latency of the service, but this is not completely dependent on the cloud service providers, if you think about it deeply a little bit, because if you say that you need a latency of around 40 millisecond, but then you select a server that is in a different continent, right? Essentially, the cloud service providers at that point of time cannot promise you a 40 millisecond latency at that point of time. So this is what I mean when I say that there is a share of responsibilities that is kind of outlined within the contract itself. These are some of the facets that will play a role in kind of determining the share of responsibilities itself, right? There are certain things which are completely within the control of cloud service providers. So specifically, since they are provisioning the service itself and the infrastructure that is going to support the service, this is something the client cannot control by themselves, right? So aspects of QoS, such as availability, lies completely within the responsibility of the CSPs, right? Whereas if you look at other quality of service metrics, right, such as latency is not completely controlled by the cloud itself, right? There are certain aspects that might result in an issue of latency. So for example, if their systems are not reliable enough, or they are not provisioning the correct processing power that you have requested, that can cause a delay or a freeze up on the execution of your processes that is running on that platform, right? And inversely, not inversely, but that would be directly proportional to how much time it takes to kind of get a feedback or a response from whatever type of application that you're trying to execute on the platform, right? So those kind of things, that is anything that has to do with infrastructure, that any QoS parameters that directly relates to infrastructure itself, that will be the responsibility of the cloud service providers itself. So it will be called CSP, or we can sometimes just refer to it as vendors, right? Cloud vendors. Okay, but anything that is a responsibility of the client. So for example, the cloud cannot dictate or control what kind of internet provider you are using as a client. So if your internet connectivity is not suitable enough to support the type of application that you're trying to execute and how it establishes the connection with the cloud, then that is not something that the CSPs will be responsible for. So you have to kind of keep that in mind. So essentially, you have to read that contract thoroughly in order to get an understanding of what is your responsibility and what is the cloud's responsibility. One of the typical aspects of share of responsibility is with respect to privacy and security, right? So here, there are certain aspects that you need to be kind of very familiar with, and you need to know that what happens in the event of let's say, a data theft or a data leak and stuff like that. What actions will be held where you can help the cloud, the CSP responsible, and which actions are going to be a responsibility of the client itself. So there's a clear distinction here, and this distinction is with respect to what we know as a service called Identity and Access Management, or IAM, and then keychain management or key management specifically. All right. So this is something that plays a very crucial role with respect to privacy and security of your applications that is running on the cloud, and the data that it is generating and then being stored in the storage volumes that you have basically that you are being basically provisioned by the cloud service providers and stuff like that. So if you read the SLA thoroughly, right, you will see that the cloud clearly states, the service provider, that any issue of security theft or security compromise or data privacy compromise that can be directly attributed to mismanagement of identity access, right, or key management, then the CSPs will not be in any way responsible, be held responsible for the consequences of the compromise that takes place, right? So essentially, what this is playing a role towards is basically access control, okay, and authorization. So authentication and basically authorization of who can access what type of files or data or processes within your system. So we will see that before we start working on any of the different services that is provided by, well, AWS in particular, in this particular use case scenario, but for any cloud provider for that matter, right? It is our responsibility to be familiar with how do we define our access control and authorization measures, right? So we need to generate our keys. We need to decide all of the users who we access, who will be able to access our virtual private service, or VPS, that we design on the clouds, right, on the public clouds, and then what is the extent of their authorization, okay? So specifically with respect to AWS, if you think about AWS in particular, there are things, and we will learn about this, so if it doesn't make much sense right now, don't worry about it. There's things called IAM roles, right? These roles define access control policies, okay, with respect to all of the different components that will be present inside your virtual private server. And what is meant by a virtual private server is that, I think I had a snapshot of it somewhere. So this is your own virtual private cloud, right? So what this means is that you can go to AWS here, okay? So this is basically the AWS boundary, right? So within the AWS boundary, what this illustration is basically showing us is the procuring or the provisioning of infrastructure as a service for some client, right? And what this does is that when you go to AWS, in order to create this infrastructure as a service, or request for a provisioning of infrastructure as a service, the first few things that you need to keep in mind is, what are the availability regions, or the AR? So that is what this region 1, region 2 is essentially reflecting, right? So availability regions are basically entire continents, right? So that means if you think about AWS's availability regions, you will have a region in North America, you will have a region in probably South America, you will have a region in, let's say, Europe, you will have a region in Asia Pacific, okay? You will have a region in Japan, South Korea, Australia, so on and so forth. You get the idea, right? So that will be a reflection of what the regions are. Within each region, there will be multiple availability zones, or better known as AZs, right? So you have to decide that where you are trying to create your virtual private cloud, where the resources that you are requesting, where will that be present, in with which AZ, right? So for a good, robust deployment of your networking infrastructure, right, it is always suggested that your resources be kind of spread across, replicated or duplicated across multiple availability zones, depending on the sensitivity of your application as to like what kind of services it is supporting, how crucial it is to keep fault tolerance and backup and stuff like that, which for production environments, it's always necessary, right? It is not an option, right? But if you're just developing and testing, just to understand, the infrastructure and how to use it, then probably you don't need to do a multiple availability zone deployment. But for this illustration, you can see here that you have a multiple AZ deployment across multiple region itself, right? So it's not necessary that you have to kind of keep your services within a particular region, because there are companies and organizations whose services are used across different continents as well, right? So for the essence of latency, you cannot just stick to a particular region if that is the situation that you're dealing with, right? So virtual private clouds, or VPC as they're better known as, is basically your networking infrastructure as provisioned by the public cloud service providers. Okay, yes, question?
Yeah, so I wanted to ask, is this the user's responsibility to decide the regions?
Yeah, it is.
Okay.
It is. You have to figure out, based on your customer base or whatever type of processes you're running, where you need to run it. So to give you a quick rule of thumb, right? It's not set in stone, and there is no template that you can follow to decide that. But if you still want to have an understanding of how I should figure that out, you need to go back and think in terms of your organization and what kind of user requests or user applications you are going to support, right? So there are only two categories. We kind of have an understanding of that, right? So are you doing a client-facing high throughput application? Is that the mission of your organization? Or are you executing something, some task that is passive in nature, that is going to take a long time? There won't be any front-facing users, and the results probably are going to be used by very few select users, right? So in that situation, that is in the HPC situation, you are probably looking at a scenario where you don't really care about latency as such, right? You do probably care about availability, because you don't want the systems to go down. So there are two facets of QoS. So let me jump a little bit back again. So where is my QoS chart? So we talked about the availability and latency, right? But if you think in terms of services itself, service provisioning itself, right? And if you think about QoS service provisioning, then you can talk about availability. That is whether the systems are available or not to begin with, right? Whether you can reach out to the system. So in very simpler terms, can you ping those systems? But there is another spectrum that is known as reliability. Okay, that is how reliable are the resources that are being provisioned to you. Does it go down very often? Does it freeze up? Can you use it? Can you not use it? So here, when you think about HTC kind of applications or tasks, right, you need to make sure that you have both availability and reliability of the systems, right? But you can argue, right? Of course, some people can say that you need availability and reliability universally across whatever the category of application you're running. But you can argue to a certain degree that if it is about a high performance computing application where you are just going to submit your tasks in a batch processing kind of request, right? And all you must make sure that you know the fact that it is going to take a while in order to complete the execution and the processing of those different tasks. So you don't need to kind of ping to that system as long as you know that system is running. So that is where the argument is coming from, that for HPC systems, that maybe the reliability is very important rather than having consistent availability, right? It would, of course, from the counter argument point of view, it will of course play a disadvantageous role from the service provider's perspective if their systems are not available when you need them, right? Even for HPC kind of tasks. But it's just a discussion to keep in the back of your head, that that is something that you have to keep in mind. There is also a question of throughput itself, because if you're talking about HTC applications, and primarily this is the majority type of applications that you will see in this day and age, right? Client-facing high throughput applications that are required, right? So throughput is basically another QoS factor that you have to keep in mind. And then finally, the last one that we already discussed is basically response time. Sometimes it is also referred to as latency of the service itself, right? So this is something that you have to keep in mind. But as far as latency is concerned, you are never going to have a problem with latency as long as you are within the networking system or the networking infrastructure of the cloud provider, because they use very high bandwidth infrastructure itself. The latency problems, as we were discussing previously, is going to arise once you leave outside of that pocket or that networking infrastructure that is specific to the cloud service provider. So remember that everything that happens within the environment of the CSP, that networking infrastructure is not necessarily the public internet. That means that they don't share the same channels of communication that you and I are right now sharing with respect to the Zoom call and stuff like that, right? They have their own dedicated network, which has a very high bandwidth capacity, right? So anything within the network, you are not going to have an issue with latency as such, right? So that is something that they can guarantee you, and that is an information that you can also find in the SLA itself, right? So coming back to this, so once you decide on your availability regions and your availability zones, and the availability zones are mostly with respect to fault tolerance and you know, making sure that you have replicas and stuff like that in order to reduce the latency within a particular region and stuff like that. And ARs, you can argue that it is for, you know, fault tolerance purposes and reliability purposes, but it's just a subjective opinion from my side specifically, that I see it as a reason to bring your processing closer to the clients. Yes.
Is there a one-to-one relationship? I mean, when you are choosing your availability region, your availability zone, you say, I've done demographics and 90% of my users are in New York, therefore I choose a New York region.
Yes, that is correct. Yeah, so you will have to go through a market research, and you are exactly right that you would want to run your services closer to your users. This is just to digress a little bit, there is a funny pattern that is going on. There is a paradigm shift that is currently going on right now. You're talking about the paradigm shift probably about a few years back right now, just to understand cloud computing and how it came to being, right? But I think around the 2014, 2015 mark, when the research in cloud computing itself started to become more and more stable, right? And it became, you know, people resolved all the issues that they were coming up. Other people's coined these terms. So there are more terms. If you want to extend that tree of paradigm that we keep talking about from time to time, you know, starting from HTC, HPC, going on to clusters and then grids and then cloud computing. So then we had this fog computing, and then fog computing kind of people, it did not, you know, it wasn't a hit, so to speak, right, with the community. But what became a hit is basically this paradigm here, which is known as edge computing. I think a lot of you might have heard about these terms before, but if you want to look into, or if you want to kind of visualize the hierarchy of where each of these computing stands, so you have the cloud at the very top of the hierarchy. And then once the people had proposed about fog computing, the fog computing is like the middle layer, right? And the edge computing is like the lowest layer. And then finally, below edge computing is where you have the infrastructure layer or the hardware layer, which is kind of supported by sensing technology, okay? Sensing-based hardware devices, okay? So in short, I can simply just say anything that falls into Internet of Things, and then there is other terminologies for it. Right now, people are trying to kind of make it a thing to rather use the term Internet of Things. They're calling it Internet of Everything. So it is slowly and slowly kind of transforming into IoE as such, but it has not yet seen a stabilized version or popularity as we are familiar with IoT itself, right? So the reason I bring this up is because if you notice here, all the discussions that we are trying to do right now, we are saying that, so this is where the client resides, right? So if you think of desktop computing, this is where the desktop computing was, right? There was no sensing aspect kind of associated with it, but this is where the desktop computing was. And the whole notion of the desktop computing is you don't bring the processing, you don't move the data to where your processing is, right? You move the processing to where your data is. And since we can create this universally accessible service that can be accessed through service-oriented architecture and basically the public internet, right? Store everything here, move your processing to the cloud, and then execute them, right? But as this paradigm shift is currently taking place, and this is currently taking place, right? The research is getting more and more intensive when it comes to this. This is still there, but people did not did not go viral, so to speak, right? If you want to put it that way, right? But this is getting more and more hot area, this area. And the whole notion of this area is the evolution of this paradigm shift is guided by what this infrastructure is doing to the computing platforms, right? The whole point is, okay, you want to move the processing to where your data is, and you want to store your data where it is universally accessible over the internet, right? Using REST API calls and stuff like that. But the problem is, this is no longer your traditional desktop computers and stuff like that. And you don't have a specific, limit-based data that is being generated. This sensing infrastructure that we have, basically the IoT infrastructure, you might have also heard about this keyword term, is generating what researchers have coined it as big data itself, right? So essentially the volume and the velocity and the variety of the data that is being generated is no longer comparable to what we were working with when we were dealing with desktop computing in general, right? So the whole idea of that, hey, let's move this data to an area where it can be universally accessible wherever you are in the world, right? And then move your processing to that location and let them handle the processing. Let them give you the infrastructure and stuff like that and let them handle the processing. But the problem is this data is very large, right? So as a result of that, you still have to make a singular, not a singular, but you have to consistently keep on pushing your data to the cloud, right? So that means there is no set of information. So if you think of very basic wireless sensor networks, and wireless sensor networks were very popular around the early 2005 to the 2010 to 12 time. It was one of the very hip technologies, right? But now it has become very stable, and the research in it has become quite stable. Wireless sensor networks eventually have kind of evolved into a subset of IoT platform itself, right? Or the IoT infrastructure itself, right? So if you think about a sensing node, right? And if you think about a sensing attribute, let's say you're sensing pollution, right? Or you're monitoring the output of any kind of industry, right? Or what kind of gases are being released and stuff like that. The frequency of sensing that takes place there is very short bursts, right? So that means maybe every minute, every 10 minutes, 15 minutes. So this data can no longer be transferred to the cloud as a batch. So this transfer line that you see here, the weird line, right? This can no longer be sent as a batch data, right? So that means you are looking at a stream of very huge volume of data. And essentially, if you have a stream, that means you are consistently using up the bandwidth, right? And that is going to kind of defeat the purpose of saving the bandwidth that initially dictated the use of cloud computing. So now the evolution as a result of this challenge resulted in the suggestion that instead of bringing all of these IoT-based data to the cloud, we need to create a platform that will be closer to the data itself, such that we don't have to stream this very large volume of data, of very different types of data that is coming at a very fast pace, all the way back to wherever the data centers for the cloud are, but we essentially tie a connection between the cloud and the edge platform, right? And move the processing to the edge platform, right? But the challenge that we are facing right now, because cloud is a well-established paradigm, right? So you have pipelines of services that can handle almost every type of job that there is, right? Even jobs that are with respect to IoT stuff, right? So we have services that are specific to IoT itself. But the problem is, if you want to save this bandwidth here for the data streaming, you need to move the processing here to edge computing, which is basically a platform that is built closer to the infrastructure itself so that you don't have to stream the data, right? So again, you're bringing the processing to the data, but now the data is no longer stored in the cloud. But here there is another challenge that you need to be facing, is because the devices that make up edge computing are not the same as the devices that make up the platform for cloud computing. You cannot just, blindly or at your leisure request for infrastructure resources that will give you, let's say, 16 gigabytes of memory and like unlimited storage space and stuff like that. You don't have devices on the edge platform that can, suitably support that. You cannot build that, right? So essentially there is a limitation. There is, depending on the use case scenario, of course, it's not universally applicable, that sometimes for some edge computing based use case scenarios, you cannot request unlimited processing power, memory, and those kind of resources that are available, right? So how do you run the initial processes that was being supported by the cloud platform and run it on the edge platform, right? So that they can work on these big data or stream of data that is being generated, right? So the cloud, right now, if you look at AWS's infrastructure itself, they say that they have things what are known as edge infrastructure. It is not a full-fledged edge computing platform as such as the ones that we were discussing here. It doesn't have the pipeline of services that supports different kind of processing like we have on the cloud, but it is mostly suitable for content distribution networks or content delivery networks, right? So essentially, if you have an application or an organization whose sole purpose is to, let's say, host videos or images, and then users can access it essentially, then you would want to move that data closer to the clients so that you can reduce the amount of bandwidth that is required to transfer it across long distances, right? So those infrastructures you can currently see on AWS as well. And you can see that AWS will promise you the fact that they have edge centers. They wouldn't call it edge regions or edge zones, right? They have these edge centers. And that is basically the whole idea of that is to create these edge centers in locations where there are no data centers. So one of the typical examples that I found earlier when I was looking into this is that we talked about the fact that we have a region in Ohio in the Midwest. The Eastern Center is handled by Virginia for AWS specifically. And then you have one in Seattle, and then you have one around the Northern California region, right? But you can see here that there is a big kind of gap around here, right? In the southern states, right? So spanning probably from Nevada almost to like Georgia and Florida. You don't have anything going on there, right? So what they're saying is that in the Texas region, they will create these edge centers such that anybody who is trying to avail the services can basically, host their applications or request for resources from those edge centers, so to speak, right? So that is some information that might be of some use, keeping in mind of that, right? So when you pick up the availability zones, you basically set up your profile. You pick up the templates of the compute instances that you see here as to like what kind of CPU it is going to use, what kind of OS distribution, how much storage will be attached to each of these different compute instances and stuff like that. So then you decide its deployment. So you as a client, you have to decide what your VPC is going to look like. So that means you need to have a pretty good understanding of how networking works, right? Because if you don't understand how networking works, it's not that you have to set up your networking from scratch, but you essentially have to decide where are you going to deploy all of these different instances based on the use case of your organization. So that is an exercise that you will have to perform, let's say, as a cloud architect, right? If you are designing, or if you're responsible for designing the cloud solution for somebody's organization. You will see a lot of companies like this out there which say that they provide cloud solutions for existing IT companies who do not have a cloud solution but wants to migrate to the cloud, right? So this is a problem of cloud migration, where you not only have to decide which part of your traditional IT computing do you want to move to the cloud, or can you move to the cloud, but it is also how you are going to design your network on the cloud itself, right? So for example, here we have a very kind of I wouldn't say stable, but a very uniform deployment here, that two regions are there, and we are creating two virtual private clouds in both of those regions, right? And then the virtual private clouds are kind of spread across two availability zones within each region, and each availability zone, keep in mind, is basically a data center, right? We say so, we don't know so exactly physically what is happening, because that is the layer of transparency that is kind of present there, right? So you can assume that these are data centers in itself, right? And within those data centers, somewhere within those virtual clusters or consolidated servers, is somewhere your instances that you're requesting through this profile selection and stuff like that is being deployed, right? So in a single go, when you're trying to establish your profile, you can decide the multi-AC deployment. There are options that you can select, and we'll see how to do that later on when we work with the demo itself. Okay. But this is how it looks like, right? It's a typical architecture. It is not driven by any kind of use case scenario, but you need to understand that you have to create your own network, right? And the reason why we talk more about this, and why we say that you need to have a good understanding of networking itself, is because for each of these availability zones, you will have to kind of decide on its firewall policies. Okay. These are sometimes known as network access control policies, or NACLs, right? You have to decide that from the outside of this particular layer of your VPC. So this is your trust boundary essentially, right? So connections can come through and out of this. Okay. So this is one layer of firewall that you have to kind of define by yourself. You have to decide what are the incoming connections that you're allowing, and what are the outgoing connections that you will allow. But in addition to the whole VPC firewall, there is also a firewall that will be surrounding the instances itself, right? So there are two layers of firewall, and we'll talk about those firewalls very soon when we talk about compute clouds. Okay. So you have to define the policies, the access control policies, essentially for your entire VPC, as well as your individual EC2 instances, or if you're working with Google and Azure, they will have something similar there. As to what these access control policies are. So you need to remember that not only there are access control policies that is applicable for the services that is going to be present within your cloud platform, but there are also network access control policies that you will have to define as well, specifying the IP addresses or the other AWS or cloud services that is out there, which can communicate with the infrastructure that you're setting up on the cloud, right? So how you set this up, this is fully on you. You decide that. The cloud is not going to tell you, let's do this or that, right? So you need to be aware of how you're going to set up your infrastructure. And this is specifically with respect to infrastructure. If you're working with platform, you just decide where you want the service to be, kind of where you want to access the service from, and then AWS or GCP, somebody will give you those services, right? And software as a service, there is nothing much to talk about. You just go to the browser interface and just, subscribe for the software, right? So I'm not going to talk much about SaaS itself, right? But what happens is that if you're trying to support this architecture that we're talking about, so this is from the perspective of the client itself, right? This architecture that we're talking about, this networking. But how would you provision this? So we need to switch back the perspective again from the perspective of the service provider. Like if you are, let's say, setting up your own private cloud, right? You cannot use all of these established infrastructure from the service providers who are public in nature, right? You can probably tie up some of their existing services if you're doing a hybrid solution, right? But if you're doing a completely private solution, you need to have some understanding of the software resources that is necessary to implement all of these different layers of a service provider, right? So we talked about some of these layers before. So for example, we talked about hypervisors. So when we are saying V, M, and then M, so this is essentially what the hypervisors are. So we discussed about the Zen architecture for hypervisors. We have talked about how you can implement the hypervisors being either bare metal or hosted hypervisors. We also talked about the functional architectures of your hypervisors as well, where you can have probably a microkernel architecture, or you can have a monolithic architecture, and you decide that, like, how do you want to implement that, right? But on top of these hypervisors, there are other software resources that is necessary, right? So essentially, at the very top layer, you have the consumers, or better known as clients, right? And they can go for all of these different cloud services, right? So whatever services that you are providing from your cloud infrastructure, they would be able to access that. So that is the first layer of interaction that you're going to have with them. But the most important layer that is beyond the hypervisor itself, because the hypervisor is something that is found at the lower levels, right? It is closer to the actual hardware infrastructure, because that's where you are applying the virtualization technology. But we talked about the fact that in between, there is a middleware. Okay, we discussed this in the last class, which is going to basically bridge the gap between the requests that is coming from the user layer, right, or the client side, and being propagated to the infrastructure layer, which is being managed by the VMware or the Zen architectures or the kernel virtual managers and stuff like that, right? So here there are different facets in the middleware, or different softwares that is responsible for specific tasks, right? So the first layer is the virtual infrastructure manager, right? Or the VIM itself, that is the managing entity of the entire data center, right? And there can be multiple of these. So you don't need to kind of memorize this as such, unless you're specifically working on it. Then you need to get accustomed to these softwares that will be used in order to implement VIM, right? So please remember, as far as now is concerned, the current situation is concerned, that be aware of their presence. That is the important thing. So that if you ever find yourself in a situation where you have to build your own, right, data center, not data center per se, but basically if you're working for a private cloud architecture and you have to implement that, or you're working with a team that is implementing that, be aware that you have to learn these softwares, or this type of softwares, right? So for example, for the VI management, you have the options for VMware again, which is the commercial one, not the one that, it's not the same one as this one. Or then there are options such as Open Nebula, right? And by the way, keep in mind that these are open source to a certain degree, right? So anybody can kind of take it as it is and then modify it based on the needs of the organization, right? And then once the data center management is taken care of, then we have to look into the middleware aspect of it that is going to bridge the gap between the user requests and routing the requests back to the infrastructure itself, right? So there are many different options which are available. So for example, for data and stuff like that, use Eucalyptus. You will also need something for the networking management. So you can use those softwares which are responsible for establishing the networking. So what I mean by the networking is that we talked about networking here. If you think of it from the client's perspective, you are not really setting up IP addresses and deciding how each IP address is going to communicate with another IP address. You are not basically setting up the route table. You're not configuring the router or anything as such. You're just saying that, oh, I have these two instances. They will be able to communicate with the outside world following the policies that are defined in the networking firewalls, and then each other in such and such manners, right? So that is the client aspect of it. But if you're thinking from the service provider's aspect of establishing networking, then you essentially need to configure the routers. You need to set up the route tables, the routing mechanisms that you're going to use in order to have the communication set up and things like that, right? So you can essentially use the open source softwares that can help you establish the routing, that can help you establish the storage and the provisioning of other resources. And that will be connected to the hypervisors essentially, right? So these will be the middleware managers, okay? And all of this has to be implemented over the REST APIs, right? So you will have to implement that as a web API protocol so that it can be accessed through the browser. And also, if you want to provide support, you can also provide support for the command line interfaces as well. So again, this is just to keep an idea of in a situation, if you ever find yourself in a situation where you have to implement the data center by yourself, you need to learn the middleware resources that essentially bridges the gap between user requests and the infrastructure layer itself, right? So make a note of it, be aware of it. You don't need to learn it right now because that's not what the scope of this course is. We're not focusing on that per se. But just keep a track of it, right? So if you find yourself in a situation, you can work on it, right? We already talked about the service models, okay, in the form of infrastructure, platform, and software. In the current day and age, you will also find some variations of these three primary services. So you can have database as a service. You can look into machine learning as a service. Right now, you also have IoT aspects like processing of IoT data that has been generated. Sensing as a service is not available as such, but there are certain providers that also provide you sensing as a service, so that if you do not own sensing devices, but you want to execute certain CPS or IoT-based applications that requires sensing, right? Then you can go to those service providers and then request to rent out their sensing devices, which are probably deployed somewhere across the field, okay? You can also get security as a services. So for example, if you want to perform penetration testing, if you want to perform security risk assessment and things like that, but you don't have the tools or the software to do so on your application, then you can essentially rent out the services of security that is provided by many cloud service providers as well, right? So again, just to wrap up this particular discussion, you need to make sure that first and foremost, you read the SLA. And the first thing that you need to understand on the SLA is to basically see what guarantees a cloud service provider is giving you, right? So if you work with a company that provides cloud solutions for companies who don't have it, or if you're doing it or working with a team that does it for your own organization, right? That is the first step that you have to keep in mind before the architecture of what your infrastructure is going to look on the cloud. Please make sure that you read the SLA thoroughly to understand what guarantees the cloud is providing you, because there will come a time that you might need to refer back to it, and also have a clear and thorough understanding of what your responsibilities are as a client with respect to this contract, right? Because that is very important. And specifically, they will talk about things of what happens during a cybersecurity attack, who are the responsible parties, because they will do a forensic analysis to kind of identify what led to the attack. Because so if it was an attack based on poor policies defined by you with respect to identity access and management, they will not take responsibility for that, right? So you need to keep in mind all of these different things, okay? So we already talked about this, so I'm not going to discuss this. You can check this illustration out by yourself, all right? And everybody has an understanding of what infrastructure as a service is. Can I get a thumbs up if there is a consensus agreement of your understanding of what this service is? Okay, so at least for all those who responded. Again, if you don't understand, you can always ask your questions. Okay, and this is basically what infrastructure as a service looks like on AWS itself. And then speaking of platform as a service, basically it is going to give you different operating system environments, basically container services, which has different libraries supposed to run specific type of applications. So some example of platform as a service on AWS itself is what they call as the elastic MapReduce. So you might have heard about this Java-based programming technology that is known as MapReduce. That is essentially a way to process very large amount of data, right? It's essentially based on this client server, not client server, but this master slave architecture, where you don't have a single master, you have these multiple masters, which are known as the mappers, and then you have multiple slaves, which is basically the reducers, right? So you essentially map the different tasks. So it breaks down the entire processing of the tasks that you kind of push to it, and then kind of maps it on all of these reducers, and these reducers simultaneously execute all these operations and then combine all the results together to give you the final results, right? So it basically runs on HDFS, okay, the Hadoop distributed file system. So you need a support for that in order to run MapReduce, right? So you don't go for the infrastructure when you're trying to run a MapReduce program. You essentially request for the environment that will enable you to run the MapReduce program, right? And there are also other supports in terms of platform as a service that is provided by AWS to run various kind of data analysis, data processing applications, querying applications. So you have in the form of Hive, Pig. These are all examples of softwares that are provided or provisioned as a service on the AWS platform, right? You can also execute traditional programming languages such as Python. You can run C++. You can run, or if you want to work on web development, for example, you have the capability of platforms that can support languages such as PHP, JavaScript, Node.js, Express frameworks, which is part of Node.js, Python, Django, and stuff like that, right? So that is essentially what development of or platform as a service, essentially the different examples consists of, right? So, and then finally, the Google App Engine is kind of integrated into the Google Cloud Platform at this point of time. There is no separation of those two services anymore. So all of the software as a service or platform as a service that previously Google App Engine used to provide, they are now integrated as a part of the Google Cloud Platform. So you can find them there itself. There are other examples as well. So these are always the well-known examples of providers when it comes to platform as a service, right? But there are other platform as a service that is also available. So some lesser known examples, but quite popular in their own regards, are known as DigitalOcean. And then Heroku is also there in order to provide you support for platform as a service, right? And software as a service, pretty straightforward. Applications that you access through the browser interface. So some of the well-known examples are the Google Suite. So you can use Google Mail, Docs, Drive, and there are many more examples. The same goes for Azure and stuff like that. And AWS has their own set of resources as well, right? So more than anything else, just like digressing again a little bit, right? AWS captures the market because it is much more famous for infrastructure as a service. So that means most of the bigger companies that are out there, right? Even if you think of startup and small scale companies, they support their business intelligence, right? Essentially through the infrastructure that they provide. And that is where AWS basically captures the majority of the market. It's not that nobody goes to Azure or GCP, even they do provide the services. But if you think about how these applications or these services or these providers came into being, AWS's sole focus back in those days when it was setting itself up, right? It pitched itself as the IaaS providers, whereas Google was mostly there for app engines and stuff like that. Azure has a following as well, but I'm not very well familiar as to what their selling factors is, other than the fact that it can support Microsoft-based services at a cheaper rate compared to the other service providers. So what I mean by that is, like, it doesn't mean that AWS does not support Windows platform or that you cannot develop .NET frameworks on AWS, but it's just that if you go to Azure itself, you will get it at a much cheaper rate because that is more like a service that is specific to them, right? So they don't have to get licenses and those kind of things from another company and then bring it to their platform, right? So that is where the difference in rates comes into the picture. Okay, so moving on to data center, the first and foremost topic that we will have to keep in mind is when you're building a data center, okay, you have to be aware of what is known as the economy of scale. And the economy of scale, what the describing factor for the economy of scale is that the larger your data center is, the lower is going to be the operational cost. Can somebody comment on this? It seems a little bit counterintuitive if you're not familiar with this concept, right? If you think about it in such a way, right? If it's saying that the larger your data center is, the lower will be your operational cost. I think this is a little bit incomplete, but per unit, right? So for those who are not familiar with this economics aspect, can you comment on this? What are your thoughts on this? For those who are familiar, please hold back for the time being a little bit and give others a chance to think.
Is it sort of similar to we'll make it up on volume?
It is, but can you elaborate on that? Like if you take this,
when you have infrastructure costs, electricity or building or whatever, and you spread them out over a large number of units, your cost per unit goes down.
Okay, that is correct. Yes, that is absolutely true. Can somebody give me an example which is non-cloud related but still follows the economy of scale? Something that we see probably on an everyday basis and all of us might be a little bit more familiar with respect to the explanation, and we can understand.
I would give an example of boats that carry containers. The bigger they are, the cheaper it would be.
That is very true. Anybody else? Anybody else? Give it a try. Don't be shy to speak. So this is my poor attempt in making a airplane. Can somebody explain the economy of scale with respect to airlines? No? Okay.
I mean,
Yeah.
for the for an airplane size, usually majority of your cargo is fuel.
Mhm.
So you would want the bigger plane that can carry more passengers with the fuel, so that
Correct.
you could scale your
Correct.
economies right there. So
Right. So think about it from an airline's perspective, right? You will have to buy a certain amount of fuel or gas to go from, let's say, location A to location B, right? So you will have to spend that amount of dollar in order to run your airplane. Okay. So if, let's say, a very big airplane, such as like the Boeing 747, okay, you have a plane like this, and you have to spend some money in order to acquire the airplane itself, right? That will be some dollar amount. And then you will have to spend some money on the gas in order to run the airplane from, let's say, source A to destination B. Okay. So now, if this airlines, let's say, takes up, I don't know, 10 passengers only, and kind of caps it at that, right? So the amount that you have to pay as a client, these 10 people have to pay, that they have to make up for all of the cost that it took in order to run this service, in order to acquire this service, and in order to maintain this service, and then profit, right? From the service provider's perspective. So if you think of it from that perspective, okay, imagine how much the tickets will cost for these 10 people. Even right now, I mean, given the current scenario, this is a bad example because it costs a lot, right? But still, think about the days when the prices were not that high, right? So if you have just 10 people, this is going to cost a lot. But if you, per unit, that is the important thing. The per person, it's going to cost a lot in order to avail these services, right? Now, if you increase this 10 people to around 320 people, then the cost per person for availing the services that will be provided by this airline is going to go down considerably. And in a way, for each individual, it's not going to cost so much in order to request for the service. And from the service provider's perspective, it becomes cheaper for them to run the airlines, because as long as they can accommodate more people without, pushing the boundaries, then they can still make up for the cost that is essentially that they incur in order to own, run, maintain, and manage the service. Okay, because there will be some upkeep that will also be involved in order to kind of make sure the airplane does not just fall apart. God forbid that happens, right? So that same policy kind of applies to data center as well. Because if you think about it, what is a data center at the end of the day? A data center is basically a location where you have a bunch of racks, and within these racks, you have all of these hardware resources that has been virtualized, and then you're provisioning services to different users through those virtual environments, right? So the more and more racks or units of commodity hardwares that you have here, then the more users that you can support. So if you create a data center, you will have to spend the same amount of money in order to host, let's say, 10 computers versus 300 or more computers, right? Because that will be the size of a data center. Otherwise, you don't necessarily call it as a data center itself, right? So the larger the data center becomes, the lower the operational cost, because there are certain fixed costs. If you remember the cost model analysis that we were discussing in the last class, right? We talked about some of the fixed costs. So there is a cost of acquiring or leasing out whatever you want to do, the location where the data center is, right? Then you have to kind of get all of these different hardware resources. You have to have the electricity to run the physical location. You need the cooling power and so on and so forth, right? So these are something that you need, whether you are going to host one machine within that location, or whether you're going to host 10,000 machines in that location, right? But the more machines that you have, that is, the more you increase the size of your data center, that will allow you to support more and more clients, right? And the more clients are there, that means the cost that will be incurred to the clients will also go down. So the clients will not shy away from the services that you're providing, okay? So it will be cheaper for them, and it will be cheaper for you as well in order to maintain it, right? So whenever you are going to set up a data center, if you ever come to a situation like this, please keep in mind, the larger that you build, the lower that is going to lower your costs itself, right? So essentially, the cloud solutions are based on these discussions, because the amount of cost that is involved in order to maintain the infrastructure itself is very large, right? So you better have a good use case scenario that is kind of pushing you in that direction, where you have to have your own infrastructure, right? So something that you have to keep in mind. Another thing that you have to keep in mind here, other than the economies of scale when you're building your data center, is that you should be able to support all of your networking that is going to happen within the data center. As we discussed about the fact, when we're talking about this IaaS service that is given by AWS itself, right? We talked about the fact that you define what your virtual private cloud is going to look like within each of these availability zones, right? But the underlying networking interconnection that is going to be present, right? And how that communication is actually going to transpire, that is the responsibility of the data center itself, okay? So in those situations, you will have to keep in mind that it is your responsibility that whatever kind of routers and routing tables and routing mechanisms that you support, that is actually up and working based on the demands of the user, by the way. Not based on what you decide as to how it should be, but basically whatever the user requests, you should be able to support that. The other problem or the other design issues that you have to keep in mind is with respect to the expandability of your network itself, okay? Data center, the servers that are there, they are procured in the form of containers, right? So somebody talked about the shipping example, right? Where the ships are bringing in these large containers of products, materials, consumer stuff, and those kind of things, right? So you can envision that there are these large rack spaces which look very similar to these containers that are being brought on the ship. So what happens is that when you need another resource, or let's say you want to expand or scale up your data center, right? Or scale out your data center, not scale up, then essentially you don't go out to Best Buy, buy a desktop computer, come back to your data center, and then plug that into your rack space. You don't do that, because data center works on a very much larger scale than that itself, right? So what happens is that you get these containers of racks itself. And what you do is that you buy that entire container, and it probably consists of like 50, 100, 200, 300 servers within that container, right? And you just plug into that container, like plug that container into your existing infrastructure, and then basically interconnect all of these different modules that you have bought in, right? So that is basically how you are going to take care of scalability within a data center itself. And of course, at the end of the day, there has to be some sort of fault tolerance and the presence of graceful degradation, right? These two things are important because you need to replicate your data and your computing resources on redundant servers, right? So that means you need to replicate both your hardware as well as your software, so that in the event of a physical failure, which can happen anytime, right? I mean, there is a certain level of reliability of the physical resources and the software resources that you are working with, right? But you can never bet on it, right? You can never bet on the fact that a new device will not go bad early, or a very old device will continue to run smoothly as it has been running for these many years that you have been using it, right? So you always have to be prepared in the back of your head that you should be able to have, or you should be able to switch or move to any of the replicas or duplicate values, depending on the use case, right? And so you need to basically have these replications and duplications present for both your hardwares as well as your softwares. There is also a notion that when you are establishing networking protocols, you need to have multiple routes. Okay, this was a topic of research in many different domains, in routing domains, wireless sensor networks, CPS as well, is how do you find efficient multiple routes across different source and destination locations, right? Because it is essential that no matter what you do, you should not have a single point of failure, right? And what happens is that you should never create something, a route which looks something like this, right? You should not have a situation where you have one switch here or one router here connecting two different networks altogether. You should have multiple switches, and you should have the connection being able to go through all of these different routers essentially that interconnects these networks. Because what happens if one of them fails, you can move on to the other routers that are present so that you do not have a disconnected networking scenario, right? So anytime you see something like this, you need to avoid this. And the way to avoid this is to basically either create alternate routes or basically have some sort of duplication so that you can switch to those duplications that you have, right? So more than design centers, these are something that general guidelines that you need to follow when you're setting up any kind of IT infrastructure or stuff like that, right? It's just that the scale of those infrastructures are basically quite inflated when you're looking at it from a data center's designs perspective. That is the major difference that you're looking at, right? And some of the issues that you're going to face when you're working with data center, and here, of course, keep in mind that we're talking about data center, but this is also a discussion on IT infrastructure management at the end of the day, right? Because if you have the required monetary resources and the capabilities to acquire, manage your own infrastructure, which people generally don't do nowadays, but if you do have it, right, then these are some of the things that you have to keep in mind if you're kind of moving your infrastructure to the service computing domain, right, where you're provisioning services over the REST API calls and stuff like that. So one of the major challenges that cloud service providers face specifically is how do you provide the QoS guarantees that you specify or assure the clients in the service level agreements? How do you make sure that you uphold that throughout the life cycle of the client using your service infrastructure, right? So this is one of the major challenges, because if your clients are not happy and if you lose your clients, then your business goes down, right? Because that is essentially where there is a key entity that you need to keep happy. If your clients are not happy, everybody will be unhappy at that point of time. So something that cloud service providers essentially face the challenge with, okay? You would also have to sustain your services. That means we're talking about availability in general. How do you give those QoS guarantees? How do you make availability? How do you manage multiple users? And this is directly responsible or kind of relating to the concept of multi-tenancy that is going to be out there, right? How do you scale up, right? Not just with respect to the infrastructure of your computing resources, but let's say if you have to grow your database as well, then how do you define the policies which is going to dictate the scalability of these different resources that is going to be present, right? Then we talked about another QoS factor. We talked about reliability. So how do you take care of reliability? How do you assure that your infrastructure that you're provisioning as a service, or the platform or the softwares that is running on top of your infrastructure that you're provisioning, how do you make sure that those things are reliable, right? So you need to use different mechanisms such as failover strategies, fault tolerance, and then essentially one of the important ones that we talked about that is supported through virtualization is the process of live virtual machine migration, right? So you need to make sure that you implement that and those are working properly, right? You have to follow the economies of scale, right? So you have to make sure that your services does not incur too much cost to the users as well as the providers, right? When you're building the data center. So you have to build the data center in such a way that you need to make sure that your clients can acquire those services at a reasonable price. And if you are familiar with, that the price of cloud usage begins in cents, right? There is nothing that has a full dollar value per se, right? So the more you use, the cents values keeps on rising, kind of plateaus at a certain point, and then it stabilizes again. And then you have to go to a different plan if you are using too much of their service, right? But for everyday users, we call it as on-demand ad hoc users, the costs are very low. And that is because they're following the economies of scale, right? The other part, which is lesser known, but very important, equally important as the QoS guarantees, is to make sure that you have security and data protection measures in place, right? So For example, if you're working for, let's say, a school, or if you're working for, let's say, a health provider, a hospital, something like this, right? And you are responsible for deciding that you want to take your data and your processing and your infrastructure to a cloud provider. So you need to be responsible, or you are essentially responsible for making sure that the legal guidelines that are around privacy policies with respect to certain applications are in place. So for example, if you are storing payment information on the cloud, you need to check the SLA and the cloud policies to see if they follow the standards of PCI DSS, right? So this is the standard for the privacy protections for payment and financial information, right? If you're working with healthcare providers and you're moving patients' data to the cloud, then you need to see that they follow the rules of HIPAA privacy regulations, right? If you're working with student data, then you need to follow the privacy regulations of FERPA, right? So you need to be kind of aware of all of these different privacy policies so that you can counter check against the cloud service providers that whether or not they're implementing those policies and whether that makes their platform suitable for the type of use case scenario that you are considering for migration onto their platforms, okay? You need to also look into their security measures. So for example, what kind of encryption protocols are they using? How are they securing data in transmission, right? What are the transport layer security that they're implementing? And of course, in this day and age, all the cloud service providers will be using the best possible service that is available to them. And then there is this niche factor that has seen a rise. I wouldn't say in the recent years, but it has been a while. But there is this subdomain within cloud computing that is known as green computing, which specifically deals with reducing the carbon footprints that are generated by the data center, okay? Since you're running so many machines within a particular location and the power that it requires, it generates a lot of carbon footprint, right? So the research that is carried out within green computing is how to kind of reduce the carbon footprint a little bit, well, or maybe considerably for these particular locations, okay? So when you're building, okay, any kind of cloud architecture, whether that be for the public infrastructure, whether private or hybrid infrastructure, there are 4 things that you essentially have to keep in mind. That is virtualizations. We talked about that. You need to know about reliability, okay? So virtualization will essentially enable cloud computing, right? And then reliability will make sure that your services are actually available, right? They don't crash at any time without any kind of notice, right? And you have measures in place that is going to safeguard against any kind of failure that does take place within this environment. The third thing that you have to keep in mind is the problem of scalability, because you can never put a static value on the demand of your clients from your infrastructure. So you always need to be prepared in such scenarios where your demand kind of shoots up. You should be able to handle down. And then once it goes down as well, you should be flexible, or as Amazon calls it, elastic. You should be able to support that, right? And essentially, this is the concept of elastic. And finally, the way you implement or provision your services needs to be efficient, okay? With regards to what kind of routing protocols you're choosing, security measures you're choosing, there has to be some set of efficiency as to how you carry out these different procedures, okay? And once you build your interfaces, you need to build it on top of Web 2.0. Okay, that was the bare minimum. Right now, it has evolved from that particular aspect, right? You need to have very strong cloud management. That is the middleware, as we keep on saying, needs to be very strong. It should be able to handle all of the different activities that the middleware is responsible for, starting from receiving the user's request, identifying the correct resources where the request needs to be mapped, invoking and provisioning the services that has been requested by the user. Okay, so that is basically the functional aspect of the data center itself. And then the security aspect of the data, where since there is some degree of multi-tenancy and resource sharing that comes with virtualization to improve resource utilization, you need to be responsible, and that needs to be executed through the middleware when it comes to the shared resources and the access of data. Okay, and basically the technologies that made sure, and this is in the past, not in the current future, but as wireless networking and broadband services became more and more reliable, the popularity of cloud computing also increased, right? If you think about it, back 10, 15 years, we had the internet that we had was the dial-up connection, right? Yeah, probably back at least like 20 years back, right? So at that point of time, imagining things such as, having a video call and stuff like that, that was something of a dream, right? I personally remember, like, just for looking up articles, it used to take so much time in order to just connect to the internet. And then, that weird sound that it used to make when you used to open the phone line and then connect it to your laptop or your desktop. Laptop was quite seldom back then as well. So, and then the strides of advancement that we have made with respect to internet connectivity is quite a lot. And right now, if you notice, we are also moving towards that, what do you call, the gigabyte or the gigabit connectivity, right? The fiber connections and stuff like that. So people are pushing towards that as well, right? So we are hoping that as the years advances, the internet connectivity is going to keep on improving and improving. Okay, for the common masses, the fiber optics and all those things are already implemented for the bigger, large scale organizations. They're already using it, right? And we need to kind of notice the fact that the technologies that is used for storage was also reduced in price. If you think about it again, 20 years back, if you had to buy an external hard drive that was like, let's say 1 terabyte, it used to cost a lot compared to what it costs right now to buy storage technologies of like 2 TB, 3 TB, 4 TB. So that kind of further enables the usage of cloud computing platforms, right? And then essentially all of the different procedures that are being implemented in order to improve the computing that can take place through or over the internet has also raised the popularity of cloud computing. Okay, so I think we will stop here. There are just like some QoS parameters that we have already discussed with respect to the service request. So you can check those out. So we have already discussed about the security measures that needs to be there, the cost that is involved, reliability, time in terms of latency and stuff like that. So check that out. There are just 2 slides here. Okay. And then some of the challenges that you have to keep in mind. I'm not going to spell it out as such. Okay. But you can take a read at this. There's nothing much to explain in this particular discussion here. And there are some additional examples that I have included for some services that are not just the 3 major pillar of the services that is being provisioned by the cloud providers. As we move forward, we have, network as a service, hardware as a service, if you need it, that was given by Intel and stuff like that. So you can read those things. These are just good to know examples rather than actual examples itself. And then I will stop the recording here. Okay. And then if you have any questions, I can take those questions at this point of time.
Hey, for